The fundamental theorem of algebra. That sounds very important, doesn't it? The fundamental theorem of algebra. If f is a polynomial of degree n, with n greater than or equal to 1, then f has at least one zero. That is, the equation f of x equals 0 has at least one root or solution. It is important to note that the zero of f, and consequently the solution of f of x equals 0, may be a non-real complex number. That just means that any function you have that has real coefficients and real exponents is going to have at least one solution. And those solutions could be real or imaginary. That's all that means. The linear factors theorem, I'm not going to read all this. What I do want to tell you is the linear factors theorem means that you can factor this into the highest exponents, that number of factors, and those factors will be linear factors. So when you do factor it, whether these be real or imaginary numbers over here on this side, all of these will be linear, which means they will begin with just an x. You won't have like x squared or x cubed up here. That's what that means. The graph of an nth degree polynomial function has at most n x-intercepts and at most n minus 1 turning points. So for this particular function, the highest exponent is a 4. That means it will have 4 or less x-intercepts. 4 or less x-intercepts. And it will have at most n minus 1 turning points. So if n is 4, that's your highest exponent, it will have n minus 1 or 3 at least, so 3 or less turning points. Now we know that because it is a 4th degree polynomial, it has this general shape, but then it does crazy stuff in the middle. Well, in this case, you have these 3 different options. Actually, there's one more that we didn't put on here. If your graph is like this, it has no x-intercepts because it never actually touches the x-axis. But the turning points are still 1, 2, 3 turning points. This one has 2 intercepts, here and here. And it still has 3 turning points. This one has 1, 2, 3, 4 x-intercepts and 3 turning points. Now what if your graph had looked like this? Goes up, just barely touches, come back down and goes across. You would have 1, 2, 3 x-intercepts in that case. So here you can see you have 0, you have 2, you have 3, and you have 4. X-intercepts, that is. Multiplicity. Let me just tell you what that means instead of reading everything. If you have your function completely factored and you get something like x plus 1, x plus 1, x plus 1, x minus 2, x plus 4. Let's make this one more. X plus 2. This is what it means. X plus 1 happens how many times? 3 times. X plus 2 happens 2 times. And x plus 4 happens 1 time. So the multiplicity of this 0, the multiplicity of this 0 is 3. This 0 would be negative 2. The multiplicity of this one is 2. This 0 would be negative 4, and the multiplicity of this one is 1. The multiplicity means how many times does it happen. This happens 3 times, this happens 2 times, this happens 1 time. Now, interesting things happen whenever you have multiplicities of different numbers. If you have an odd multiplicity, then your graph will actually cross the x-axis at the point x equals -1. If you have an even multiplicity, your graph will just touch it. It will actually stay on the same side on both sides of this x-intercept. So I just call it touches it there. This one is odd, which means it will cross at that point. So let's go to the next page and see how this works. Let's say that we have this function at the top of the page. If you were to multiply this function out, you would get all of this. That's a really big function, right? So let's look at it in factored form. What are all the zeros? Well, what would make this factor equal to 0? That would be 9. What would make this factor equal to 0? That would be -2. How about this one? That would be 1. And this one, what would make that 0? That would be -6. Now fill in the multiplicities. X minus 9 happens once. X plus 2 happens twice. X minus 1 happens 4 times. And x plus 6 happens 3 times. This one is odd, this one is even, this one is even, and this one is odd. Now based on that, you should be able to tell whether the graph is going to touch or cross the x-axis at these x-intercepts. Since it is odd, it will cross. Since it is even, it will touch. Odd, it will cross. Keep in mind, for the Hawkes learning system, touch, this is just my word, but for the Hawkes learning system, it means stay on the same side of the x-axis. So let's plot those x-intercepts. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have one at 9. We have one at 1. We have one at -2 and at -6. We know that this is an even degree polynomial, so the general shape is this, with crazy stuff in the middle. So we know that the graph is going to fall from this side. What will it do at -6? It will cross. But be careful, at -2 it will just touch. So you're going to go down, come back up and just touch, go back down. What will it do at 1? At 1 it will also just touch. So it goes up and it comes back down. But what does it do at 9? At 9 it actually goes across the x-axis. Keep in mind that if you do have a multiplicity of 2 or more, the graph will flatten out near that 0. So for all of these, it actually gets a little bit flatter at those points. So this would be a little bit flatter here, closer to the x-axis, and also at 1 and -6. So it gets a little bit flatter here, and here not so much because it's just going straight through that one. So let's sketch the graph of this polynomial. The zeros are 1, 2, and 3. The multiplicity would be 4, 1, and 1. This is even, odd, odd, which means it will touch, it will cross, and it will cross. So whenever you draw the graph, you will plot the points 1, 2, and 3 on the x-axis. Then you will notice that whenever you get to the 1, it's going to flatten out a little bit. It will touch the x-axis and then go back up. By the way, what is the degree of this polynomial? This happens 4 times, so that's 4. Here's another one that's 5. Here's another one that's 6. So your graph again looks something like this with crazy stuff in the middle. So it's going to come down. It's going to, which one comes first? The 1 is going to touch. It's going to flatten out and touch. Then it's going to go back up. And it's going to come back down and cross at 2. And then come back up. And it's going to cross at 3. So it will look something like that. I actually have a better picture for you right here. You can even calculate the y-intercept. Do you remember how to do that? You would let all of these equal to 0. So then you would have negative 1 to the 4th, that's going to be 1, times negative 2, that's negative 2, times negative 3 is 6. You can see that it does cross the y-axis at 0, 6. The conjugate roots theorem simply means if you have an imaginary or a complex number that is a 0 of a function, then its conjugate is also a 0 of that function. So this one says, given that 2 plus 3i is a 0 of this polynomial, factor it completely. If 2 plus 3i is a 0, then 2 minus 3i is also a 0. This is the conjugate of this one. So remember, whenever you write out the factors, it's x minus each of those. So that would be x minus 2 minus 3i and x minus 2 plus 3i. So what we can do is multiply all of this out, find out what that is, and divide it into this polynomial so that we can make our factoring process a little bit shorter. So what we want to do is multiply these two out, and what I would like for you to do is multiply it on your scratch paper and see if you come up with this. X squared minus 4x plus 13. So once you get this, you know that this is a factor of this because these two are factors of this. So you can divide it, x squared minus 4x plus 13, into this polynomial. And your remainder must be 0 for this to be a factor. So go ahead and do this division and see if you get what I get. So you might want to pause this for a second. Once you do this long division, you end up with x squared minus 7 as one of your factors. This means that so far we have f of x is equal to x squared minus 4x plus 13 and x squared minus 7. We want to factor this completely. So what we need to do is find out what would make this 0. X squared minus 7 equals 0. So x squared equals 7, which means x is equal to plus or minus the square root of 7. So to factor this completely, this one we already have the factors up here. So we're going to have x minus 2 minus 3i, x minus 2 plus 3i, and for this one it will factor into x plus the square root of 7, x minus the square root of 7. We have now factored this polynomial completely.